And so that's what JWST is for, mapping the first billion years of galaxy formation and growth in the universe.
In a moment that has left scientists and astronomers on the edge of their seats, the James Webb Telescope has shattered the very foundation of our understanding of the universe's origins. For years, the debate over the theory of how our universe came into existence has raged among the brightest minds in the scientific community. But now, a groundbreaking discovery made by the JWST has thrown everything into disarray. This discovery revolves around the enigmatic concept of time and its existence within our universe. Brace yourself for a revelation that no one saw coming. Could it be possible that time, as we know it, is nothing more than an illusion? Join us as we delve into the jaw-dropping findings of the James Webb Telescope, unveiling a mind-bending truth that challenges our very perception of reality. The long-standing Big Bang theory, which explains the expansion of our universe from a hot and dense state billions of years ago, has been shaken by captivating images captured by the groundbreaking James Webb Space Telescope. These images have left not only lay people in awe, but also the most seasoned cosmologists and astronomers puzzled. The impact of these images reverberated through the scientific community, prompting the publication of several technical papers dissecting their implications. These papers revealed galaxies that defied expectations, remarkably small, remarkably smooth, and remarkably ancient. However, the surprises didn't end there, and not all were welcomed with open arms. In fact, the title of one paper began with the startling exclamation, "Panic!" The reason behind this panic lies in the fact that these JWST images consistently challenge the very foundations of the Big Bang theory. For decades, this theory has been upheld as scientific truth, but now, faced with contradictory evidence, experts find themselves in a state of turmoil. If the Big Bang theory, which has enjoyed widespread acceptance for so long, proves to be flawed, it raises profound questions about the entire scientific landscape. What other cherished beliefs might be called into question? The sheer magnitude of concern among astronomers is alarming. Alison Kirkpatrick, an astronomer at the University of Kansas, candidly admits, "Right now, I find myself lying awake at 3 in the morning and wondering if everything I've done is wrong." And the reasons behind this concern are not difficult to grasp. These too smooth, too old, too small, and too numerous galaxies captured by the JWST present a fundamental challenge to the Big Bang theory. According to our understanding of an expanding universe, objects such as galaxies are not meant to appear smaller as distance increases. They should appear larger as their light reaches us. This stands in stark contrast to non-expanding space, where objects appear diminutive compared to their distance. Yet the JWST images unveiled galaxies that defied this expected behavior, shrinking in size the farther they were from us. Even galaxies more massive and luminous than our own Milky Way looked 2 to 3 times smaller in the JWST's image compared to those captured by the venerable Hubble Space Telescope. Furthermore, the proponents of the Big Bang theory were eager to observe galaxies in a state of chaos and disarray. Yet the James Webb Space Telescope delivered images of galaxies that were surprisingly orderly, displaying elegant spiral forms and smooth, pristine disks resembling the galaxies we see in the present day. This data dealt a fatal blow to the theory of galactic mergers. Without significant mergers, it becomes implausible for tiny galaxies to grow 100-fold in size. Consequently, these galaxies were not initially small, shattering the optical illusion associated with the expanding universe theory. In essence, the absence of the illusion means there is no expansion, and this revelation has sent shockwaves through the ranks of Big Bang supporters. If galaxies appear both minuscule and sleek, it signifies the absence of expansion, and by extension, the non-existence of the Big Bang. Moreover, in line with the Big Bang predictions, theorists anticipated a diminishing number of galaxies as the James Webb Telescope peered deeper into space and further back in time, ultimately leading to the absence of a cosmic dark age. Yet another paper revealed that galaxies as large as our own Milky Way were already abundant within a few 100 million years of the proposed Big Bang event. The authors of this paper also highlighted the astonishing revelation that the new images showcased over 100,000 times more galaxies than previously predicted at redshifts exceeding 10. The formation of such an immense number of sizable galaxies in such a short time frame defies plausibility, providing further evidence against the Big Bang theory. This compendium of revelations serves to challenge the notion of time itself, calling into question its very existence. According to one fascinating theory, time itself is nothing more than a construct crafted by humans to distinguish between the present and our perception of the past. It suggests that the concept of time is essentially an illusion woven from our memories. In this theory, embraced by a group of esteemed scientists exploring the enigmas of the universe, everything that has ever occurred or will occur is unfolding in the eternal now. While many individuals rarely contemplate the nature of time, the laws of physics offer no definitive evidence that time must progress solely in the forward direction as we perceive it. The laws of physics possess a proportionality that allows time to traverse in both forward and backward directions with equal ease. In fact, proponents of the Big Crunch theory speculate that as the universe ceases its expansion and initiates a contraction back upon itself, time will follow suit and unravel in reverse. This envisioned scenario implies that as the universe diminishes in size, it will grow hotter. To envision this, picture a reverse counterpart to the Big Bang. Instead of cooling and expanding, the universe intensifies in heat while contracting. Eventually, every element within the cosmos collapses into a minuscule point where it all began. But what comes next? You're not alone if you find yourself pondering this question. Throughout history, humanity has contemplated the aftermath of a big crunch. Some propose the notion of a fresh start with another Big Bang, while others entertain the idea of the universe bursting like a bubble in a new realm. A few even postulate that this cyclic process repeats multiple times, giving rise to an abundance of parallel universes. The quandary surrounding our perception of time moving solely in a forward trajectory has compelled scientists to question its essence. As a result, some have arrived at the conclusion that time is merely a human construct. They propose a block universe, a fusion of space and time known as spacetime. This theory finds support in Albert Einstein's theory of relativity, which asserts that time and space are interconnected components of a four-dimensional structure. Every event that has transpired finds its coordinates within this framework of space-time, allowing the past and even the future to coexist with the present, rendering every moment equally significant. Physicist Max Tegmark from the Massachusetts Institute of Technology broached this topic, remarking, "We can view our reality as either a three-dimensional realm where events unfold over time, or a four-dimensional domain where nothing truly changes. If the latter depiction holds true, then change itself becomes an illusion because everything exists simultaneously, past, present, and future, at every given instant. We perceive the past as having transpired and the future as yet to occur, but in reality, they are ever present within the fabric of space-time." Julian Barber, a British physicist renowned for his writings on time, offers his perspective on the matter. Describing the existence as a series of nows, he shares, "All I am ever aware of is my brain's state. I only perceive a past because my brain holds memories." In his conversation with physicist and author Adam Frank, documented in the book About Time, Cosmology and Culture at the Twilight of the Big Bang, Dr. Barber delves further, elucidating, as we journey through life, it seems as though we traverse a sequence of nows, and the question arises, what are these nows? You can envision them as points on a landscape or a country, which I refer to as Platonia. Within Platonia, each point represents a now, and this timeless expanse emerges from the perfect mathematical rules governing it. He went on to emphasize that our perception of the past is merely an illusion constructed within our minds. This brings us back to the brilliant mind of Albert Einstein and his groundbreaking theory of space-time. However, this theory has sparked some confusion in the realm of physics, leading scientists to contemplate an intriguing question. What if Einstein was mistaken? Could discarding the notion of space-time actually pave the way for a deeper understanding of the universe? That would undoubtedly be a monumental shift. Yet, as history has shown, revolutions are the lifeblood of scientific progress. underlying currents of unrest eventually surge forth, giving rise to a new order that takes hold. For over a century, Albert Einstein's space-time theory has reigned supreme, quashing any contenders to its throne. The pivotal discovery of gravitational waves in 2015 served as a resounding triumph. Yet, like its predecessors, it too may soon face the possibility of being overthrown. The cause of this potential downfall lies in its incompatibility with the formidable quantum theory, another prominent entity in the physics realm. The quantum world is renowned for its baffling nature, where particles can exist in two places simultaneously, among other peculiarities. In the 1930s, Erwin Schrödinger illustrated this awkward concept through his famous thought experiment involving a cat, a sealed box, and a quantum state-dependent mechanism poised to determine the cat's fate. Quantum physics asserts that until a measurement is made, the particle exists in both states simultaneously, leaving the vial intact and broken, and the cat simultaneously alive and dead. However, this depiction cannot coexist harmoniously with the continuous smooth fabric of space-time. Even Sabine Hossenfelder, a theoretical physicist at the Frankfurt University for Advanced Studies, acknowledges this quandary, stating that a gravitational field cannot be in two places at once. As per Einstein's space-time, it becomes distorted by matter and energy. Nevertheless, quantum physics proposes that matter and energy exist in multiple states concurrently, occupying different locations simultaneously. Thus, Hossenfelder poses a pressing question: where does the gravitational field reside? Regrettably, no answer currently exists, leading to a sense of unease. Attempting to merge general relativity and quantum theory proves challenging. They do not seamlessly align. Above a certain energy threshold, the calculations yield probabilities greater than 1, violating the principles of inevitability. Conversely, calculations sometimes yield the value of infinity, which lacks tangible physical meaning. Consequently, these two theories stand in mathematical inconsistency. Therefore, akin to many monarchs throughout history, physicists strive to forge an alliance between these rival factions in search of harmony. Their quest centers around unifying quantum theory and gravity, a grand diplomatic endeavor aimed at persuading these rivals to share the throne. And according to physicists Lauren Friedel, Robert Lee, and George Minich, space-time shouldn't exist independently of the objects it encompasses. Instead, they propose that space-time is an intricately woven tapestry, defined by the intricate dance of objects interacting within it. In this view, space-time becomes an artifact of the quantum world itself, a companion rather than an entity to be merged. George Minich adds, it may sound audacious, but it offers a remarkably precise approach to the problem. What are your thoughts on these captivating theories? Share your insights and opinions in the comments section below.